Solving linear equations, written and read by Denis, Dalaba. Introduction. Some examples of linear equations are x add 3 equals 11, 2y equals 4, 1/3 t minus 5 equals 20, 4 into x minus 1 equals 31. Now if you study these examples, you have an idea of what linear equations are. So look at the 4 examples below and then try the questions in activity 1. So activity 1, tick or put a ring around the linear equations. This is not, that is a linear equation, 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 that is not a linear equation, that is not a linear equation, this is a linear equation, and that is not a linear equation. So study them carefully. You have an idea of what linear equations are. So going over, x squared add 1 equals 5 is not, x add 3 equals 11 is a linear equation, half t add a quarter equals 0 is a linear equation, 7h equals 35 is linear, 3y add 1 equals 9 is linear, 3y cubed add 1 is not, equals 40 is not linear, 8 minus g cubed equals 7 is not a linear equation, and minus 3 minus r equals 15 is a linear equation. In simple terms, linear equations have got the highest power to be 1. So that's 3 to this basically 3 to the power 1, and y to the power 1, x to the power 1, t to the power 1, h to the power 1, r to the power 1. The highest power is 1. Activity 2. We are now going to look at how to solve very simple equation. Solving an equation simply means find the value that makes the statement true. So x add 3 is 5. We know by simple inspection that 2 add 3 will be 5. Therefore, x is 2. So we say x is 2. 2n equals 20 means 2 times the number should give us 20. We know that 2 times 10 is 20. That means that our n is 10. And v divided by 5 should give us 7. We know that 35 divided by 5 is 7. That means that our v is 35. Activity 3 gives us some key information to help us with solving equations. 3 add minus 3 will give us 0. Minus 2 add 2 will give us 0. And a add minus a gives us 0. A number plus its additive inverse always gives the answer 0. So 3 has minus 3 as its additive inverse. Minus 2 has got 2 as its additive inverse, and a has got minus a as its additive inverse. If you add them, you get 0. Another important property to learn is the following. 5 times 1/5 will give us 1. 1/7 times 7 will give us 1. 2 9 times 9 over 2 will give us 1, which implies that a number multiplied by its inverse or reciprocal will always give us 1. We're going to apply that on these questions. So activity 4. X add 3 equals 7. We know from the property above that if we add a number to its additive inverse, we get 0. So we can apply that here. So we have x add 3. So we add the additive inverse of adding 3, which will be minus 3. And we do the same to the side. So that will mean that that will turn to 0. So we have x equals 4. That's our answer. Over here we have y minus 9. The additive inverse of minus 9 is to add 1. 9. So we add 9 to this side and add 9 to that side. Adding 9 will turn it to 0, so we get y equals 21 add 9, which gives us our 30. Activity 5. So activity 5, yeah. 15m equals 45. We know that if we times the number by its inverse or reciprocal, we get 1. So what we could do is we times here by 1/5 and times here by 1/15, sorry, 15th, and times here by 1/15. This turns to 1. Therefore we have m equals 45 over 15, which is 3. Over here, the additive inverse of multiplying by 12 is to divide by 12 or times by 1 over 12. So we divide by 12 and we can divide here by 12. So we get b equals 6 over 12, which is half. Next example, the additive inverse, or sorry, the multiplicative inverse here is with 0.5 times t, so we'll divide by 0.5 and divide by 0.5, or we times by 2 and times by 2, so that gives us 14. So t is 14. One way to do that is to consider 0.5 t equals 7 as half t equals 7. Now the multiplicative inverse of multiplying by dividing by 2 or multiplying by half is to multiply by 2. So you're going to get t equals 14. X over 4 equals 3. Dividing by 4, the multiplicative inverse of dividing by 4 is to multiply by 4. So x will be equals to 3 times 4 to give us 12. So c will be equal to 5 times 9 to give us 45. Y will be equal to 16 times 0.5, which gives us 8. Remember, 0.5 is the same as half. Over here, 2/3 times y equals 12. There are 3 ways you could do that. 2 times y over 3 equals 12 is one way of seeing it. In that case, the multiplicative inverse of times by 2 is dividing by 2. So I can divide both sides by 2, so I'll get 1/3 y equals 6 if I divide by 2. Then because it's dividing by 3 here, we do the multiplicative inverse by timesing by 3. Therefore y will be equals to 6 times 3, which is 18. So y is 18. Or 2y over 3 equals 12. We have 2y will be equals to 12 times 3, and therefore y will be equal to 12 times 3 divided by 2, and that will give us the same thing. This will give us 6 times 3, which equals 18. Activity 8, we subtract 3 from both sides, so we get 5x equals 15, and divide by 5, so x will be 3. But 4w, because it's minus 7, we add the additive inverse of minus 7 is to add 7, so we're going to have equals 21 add 7, which gives us 28. So 4w is 28, therefore w will be equal to 7. We have 1/3 x will be equal to that the inverse of positive 2 is minus 2, so we have 9 minus 2. That gives us 7. So 1/3 x is 7, therefore x is 7 times 3, which is 21. We start by subtracting 1, so we're going to have 2 over 7y equals 10. Then we can divide by 2, so we get 1/7 y equals 5, therefore y equals 5 times 7 to give us 35. 6m will be equal to 2 add 5, gives us 7. 6m is 7, therefore m is 7 over 6. Remember, a fraction is a number, so you can leave your answer like that. We have minus 2y will be equal to 3, take away 9. So minus 2y will be equal to minus 6. Therefore y will be equal to minus 6 over minus 2, which gives us 3. This example has got a bracket. So to start with, we check we have 2 and we have 21. So 2 is not a factor of 21, so the best thing to do in this case is to multiply the brackets. So we're going to get 2x add 10 equals 21. We subtract 10 from both ends, so we get 2x equals 11. Therefore x will be equal to 11 over 2. Fraction is a number, so we can leave our answer like that. The next one, start by checking. That is 4 and that is 20. So 4 is a factor of 20. So we can start by dividing by 4. So we divide here by 4, so that y plus 2 equals 5. Therefore y will be equals to 5 minus 2, which is 3. Now this example is here to explain the fact that it's not necessary to always have to expand the bracket. It's easier to divide by the common factor first. So we have 700 and we have 1000, so we can divide by 100. So we're going to get 7 into 2x minus 1 will be equal to 10. That's our starting point. Instead of multiplying by 700, we can divide by 100 for a start before we multiply. So we're going to get 14x minus 7 equals 10. Therefore 14x will be 10 add 7, which is 17. 14x is 17, hence x is going to be 17 over 14. Activity 10. This is a case with fractions. So this is the way I will do it. It's a 14 as a denominator and this 2 as a denominator here. So I can start by multiplying here by 7 to create 14 and multiply here 2 by 7. That will mean that I'm now going to get 3t over 14 equals 63 over 14. That implies that 3t will be 63, therefore t is going to be 63 divided by 3, which is 21. Another way could be, I've got 3t over 14 equals 9 over 2. I can start by dividing both sides by 3. So I'm going to get t over 14 equals 3 over 2. I'm dividing that by 3, dividing this by 3. I can then multiply by 7 and multiply here by 7. That becomes 21 over 14 is the same as t over 14. Since the denominators are the same, it implies my t is 21. Over here, I've got 3 as a denominator and I've got 5 as a denominator. I can create the same denominator by multiplying here by 3 and doing the same to that side. Then multiply here by 5 and doing the same to this side. That therefore gives me 5 times 7 equals 6m times 3. The denominators are the same, so I don't need that. This implies 35 will be equal to 18m. Therefore my m is going to be 35 over 18. Here I'll start by grouping like terms. Activity 11. There's 7 x here and there's an x here, so I subtract x from both ends. I'm going to get 6x plus 1 equals 13. I then subtract 1 from both ends to get 6x equals 12. Divide by 6 to get x equals 2. This is b. So I group the like terms by adding b to both sides. I'm going to get 5b add 12 equals 16. Because this is minus b, I add b to both sides. Additive inverse property. That means that 5b equals 16 take away 12 to give me 5b equals 4. Therefore b will be equals to 4 over 5. Next one. Grouping like terms again, I'll subtract 2y from both ends. I'm going to get 5 add y equals minus 9. Then this is adding 5, so I subtract 5. So y equals to be minus 9 minus 5. Which gives you minus 14. So y is minus 14. So I've got my 3y. I subtract 2y to give me y. So 5 plus y equals minus 9 because minus 9 stays there. I then subtract 5 from both ends. So I'll get y equals minus 9 minus 5 to give minus 14. Next one, activity 12. Yeah, activity 12, yes. Activity 12. So I start by adding 7 to both sides. So I'm going to get my 1/3 x equals, I'm adding 4 to both sides because that's minus 4. 7 add 4. That gives me 11. So 1/3 x equals 11. Therefore x will be equal to 11 times 3 to give me 33. Because it's add 1, I subtract 1 from both ends. So I'm going to get 2/7 t equals 4. Then I can divide through by 2. So I'm going to get 1/7 t equals 2. Therefore t is going to be 2 times 7, which is 14. I'll start by adding 3 because it's minus 3 here. So I'm going to get 4y over 5 equals 17 add 3, which is 20. Therefore 4y over 5 equals 20. There's 4 is a factor of 20, so I divide by 4. So I'm going to get 1/5 y equals 5. Therefore y equals 5 times 5, which is 25. I'll start by multiplying by 11 because it's dividing by 11. So I'm going to get 7 minus 3x equals 9 times 11, which is 99. So 7 minus 3x is 99. I subtract 7 from both ends. I'm going to get minus 3x equals 99 minus 7, which is 92. So minus 3x equals 92. Therefore x equals to 92 over minus 3, which is going to be the same as negative 92 over 3. Remember, a fraction is a number, so I can stop there. Question 8. Page activity question 5, sorry. So I'll start by 11, subtracting 11 from both ends. So I'll get minus 4k over 5 equals 1 minus 11, which is minus 10. So minus 4k over 5 is minus 10. This means I can multiply by 5. I can get minus 4k equals 5 times minus 10. It gives me minus 50. So minus 4k equals minus 50. Therefore k will be equal to 50 over 4. Or negative 50 over negative 4. Which is the same as 25 over 2. So k is 25 over 2. Question 6, I multiply through by 5 because this is dividing by 5. So I'm going to get 4x plus 1 equals 10. So 4x is going to be 10 take away 9. 10, so 10 take away 1, which is the 9. So 4x equals 9. X will be equals to 9 over 4. Question 7. Start by multiplying through by 3. So I'm going to get 2x add 1 equals 24. I'm going to get 2x will be 24 minus 1, which is 23. Therefore 2x is 23, hence x equals to 23 over 2. Multiply by 5, so I'm going to get 6 into x minus 3 equals 5 times 7, which is 35. So 6 into x minus 3 is 35. I multiply through by 6, I get 6x minus 18 equals 35. 6x would therefore be 35 add 18. It gives us 53. So 6x is 53, therefore x is going to be 53 over 6. Question 9. I've got 2 here and I've got 4. I can times here by 2 to create a denominator of 2 and times here 2 by 2. So I'm going to get 2 into 5y add 1 equals y add 3. This denominator is now 4 and that's now 4, so I just work with the numerators. That means that if I expand this, I'm going to get 10y add 2 equals y add 3. I do not have any fraction in this line because I have a denominator of 4 and a denominator of 4, hence I can equate the numerators. So 10y take away y will give me 9y, and then I've got my 3 take away 2. That means 3 take away 2 is 1, so 9y is 1, therefore y is 1 over 9. The same principle here, that's 2 and that is 4, so I times here by 2 and times here 2 by 2. So I'm going to get 2 into y add 1 plus y add 3 equals 5 over 1. So what the best thing to do here is put over 1 here. That means I can times here by 4 and times here by 4. So that now becomes times 4 times 4. So this denominator will not be needed as well. I'm going to repeat this bit. I'm going to cross it off and redo it neatly here. So number 10, I've got y plus 1 over 2 add y plus 3 over 4 equals 5. To start with, I'll put over 1 here to create a fraction for all the terms. Then I've got 2, 4, 1. That means I can have a common denominator of 4. So I times here by 2 and times here by 2. That is 4 already, so that's okay. I times here by 4 and then I'll times here by 4. So I've created a common denominator of 4 for each of the terms. Therefore, that will not be needed because the denominators are the same, so I just equate the numerators. So I'm going to get 2 into y add 1 plus y add 3 equals 20. Expand this to get 2y add 2 add y add 3 equals 20. This plus that, collecting like terms, will give me 3y add this and that, 5 equals my 20. Hence 3y will be equals to 20 take away 5, which is 15. Therefore my y is going to be 5. Last set of questions. Activity 13. This equation is written in ratio form, so we can change it into equivalent fractions. So I have x over 3 will be the same as 6 over 5. Then I create the same denominator by times here by 3, times here by 3, then times here by 5, times here by 5. So I've created the same denominator, hence I'll just equate the numerators. I'm going to get 5x equals 18. Therefore, x will be 18 over 5. Fraction is a number, so I'm done. Next one, I can use the same approach. 4y over 20 equals 8 over 30. I can start by simplifying this up. 4 into itself 1, 4 into 25. So I'm going to get y over 5 equals 2 here 4 and then 2 here 15. So I'm going to get 4 over 15. I'll then times here by, I can times here by 3 to create 15 and times here 2 by 3. So I'm going to get 3y equals 4. therefore y equals 4 over 3. Over here, the w, or the what I'm solving for, is this bit. So I'll start writing my fraction using in this way. So I have w over 7, and that will correspond to 14 over 11. Times here by 7 and times here by 7 to get 77, times here by 11, times here by 11. That means I've got 77 as a common denominator, therefore 11w equals 14 times 7, which is 98. So 11w is 98, therefore w will be 98 over 11. Done. Next one, I've got that together, so I'll write 5 at p over 9 equals 20 over 16. I can simplify the right hand side. 4 here 5, 4 here 4. So I'm going to get 5 plus p over 9 equals 5 over 4. Times here by 9 and times here by 9, times here by 4 and times here by 4 to create the same denominator. That means that 4 into 5 plus p equals 5 times 9. The right hand side becomes 45. So then I expand here to get 20 plus 4p is 45. So I have 45. 4p would therefore be 45 minus 20, which is 25. So 4p is 25, hence p is going to be 25 over 4. Quite easily done.